Hey, chemistry class, good to see you again. It's April 1st, and this is no Fool's Day at all. This is for real. I'd like for you to turn to page 401 in your hymnals. If you don't have it with you, you should have, but go ahead and go get it now. Just stop me for a minute. Okay, you're back. So we're going to start on 401 with the next chapter. All of those gas laws are behind us. Isn't that great? Hallelujah. We're going to go with heterogeneous mixture versus homogeneous mixtures. Now, we learned about this a little bit earlier in the book, like right at the beginning, but I'm going to review. A heterogeneous mixture is non-uniform. The particles in there are not dissolved. And so here's a heterogeneous mixture. It's some potting soil. Now, the potting soil has all of these little white things in it. You probably can't see it, white things and black things, and it's just irregular. The size of particles are big, some are small, some are wood chips, some are soil and those kind of things. That is called heterogeneous. All right. Now, homogeneous mixture, on the other hand, is where you go ahead and you dissolve things. It's called a solution. And that's what we're really studying in this chapter. So salt dissolves. You go ahead and put some water on it like this. The particles of salt, which are called NaCl, solid particles, when you put them in water, it breaks down into sodium ions and chloride ions. And those are dissolved in water, so we'll call them aqueous. Okay, and you're putting it in water, and you're forming ions that are swimming around in the water. You see, it's water with ions, water with chloride ions, and it's just all evenly spread. Now, there is no point where there is salt up here and not over there. Oh, wait a minute, it's sitting on the bottom. That's because it's saturated. There's so much salt in there that there's too much for this little tiny container. Now, the salt is called the solute, and the water is called the solvent. Okay, if it's like a liquid in a liquid, like alcohol and water, then the solute is the thing that there's less of. And the solvent is the wet thing that there's more of. So liquid and liquid, you can determine it based upon what there's more of, that's the solvent. Now the question is this: if there were no particles in the bottom, wouldn't the salt that did dissolve, wouldn't it spread evenly throughout the container? Yes, it would. Okay, so solutions, by soluble, we mean capable of being dissolved. Look at the picture of the milk, and the milk has fat globules that are big and fat globules that are small. It's a heterogeneous mixture. When you look at it under the microscope, you can see the particles are irregularly spread throughout. And the homogeneous mixture is evenly spread throughout. So what is Raisin Bran cereal? It's heterogeneous mixture. What is sugar water? Like a Coke. That's a homogeneous mixture. And a homogeneous mixture is called a solution. And let's turn the page to 402. The solution is a homogeneous mixture of two or more substances in a single phase. It's not like you've got oil that rides to the top of water. Those are two phases. But it's like sugar that is dissolved in the water and spread evenly throughout. Okay, it's a single phase. The solvent is the dissolving medium, and the solute is the substance that is dissolved. And the solute, of course, is the component that is of lesser quantity. You can pour this salt water right here through a filter paper, and it'll drain right through the filter paper, because the filter paper is actually a mesh, and it's like holes in it, if you please, like a colander. and the water just goes through with the salt because the salt pieces, these little ions, they're smaller than molecular size. They're atomic size particles. And that little mesh looks huge, and it just flies right on through with the water molecules. So solutions are evenly spread throughout. There's a metal solution on my finger right here. Look on 403. You see, this is 14 karat gold. If you look at the picture there, you'll see 14 karat gold is an alloy. Say alloy, of course. That's a solution, an evenly spread throughout mixture of metals. You got gold, you got copper, and you got silver. Of course, gold is in the largest quantity, and it says it's 14 karat, and for some reason, 24 is the magic number. So 14/24 of this ring is gold. If you had 24 karat gold, that would be 24/24. That would be 100% gold, 24 karat gold. And the heat from your finger would cause it to just melt and just come rolling off your finger because it is so soft. But when you put it into an alloy, it becomes harder and even more resistant, oftentimes, to tarnish or oxidation, and stronger as well. Now let's look at some solution combinations on 402. Look on page 402 and you see, what's a gas in a gas? Example, oxygen and nitrogen. I'm breathing it right now. It's a solution. However, if you put a gas in a liquid, carbon dioxide in water, that's like carbonic acid. That's like the carbonation that we drink in our Coca-Cola. All right, liquid in liquid, the example is alcohol and water, and they do mix. It's alcohol and drinking. It's alcohol and driving that doesn't mix, but alcohol and water do mix. All right, and that's a solution. Liquid and solid is mercury and silver and tin. It's a dental amalgam. And solid in liquid would be sugar and water, and a solid in a solid would be like an alloy of copper and nickel, and it's called Manel. Okay, suspensions, what are they? If the particles in the mixture are so large that they settle out, then it's called a suspension. It's not called a solution. In this chapter, we're really interested in solutions, but if you want to make a suspension, you simply get stuff that settles out. This right here will settle out. It's orange juice because I bought the orange juice that has pulp in it. And pretty soon you're going to find the pulp on the bottom. So you got to shake it up before you drink it to get that pulp to agitate up in there. Another one would be that, where did I put it? Right here. This right here is a suspension because it's dirt in water. And after a while, that dirt is going to settle out down at the bottom of the water. In fact, looks like a lot of it are wood chips that's rising to the top of the water. And that would be two phases. So that is a heterogeneous mixture called a suspension, not a homogeneous mixture, which would be called a solution. Okay, a heterogeneous mixture could also be a colloid, and that's where the particles are medium in size, and they don't settle out. Colloids don't settle out like suspensions do. An example of a suspension, let me go back to that, would be the Mississippi River. As long as it's agitated, the mud stays up in the river. But as soon as it hits the Gulf of Mexico, wham, all the dirt comes out, and it makes the delta region down there on the bayou. But you've got, as long as it's agitated, it's going to stay up. Colloids stay up naturally. They don't have to be agitated. So we've got two things in a colloid. It's not the solvent and the solute. Instead, it's called the dispersed phase and the dispersing medium. See on the bottom of page 403? The dispersed phase is like the solute. It's like the salt. And the dispersing medium is like the solvent. It's like the water. So those are just different words we use for the word colloid. Okay, And so some examples would be emulsions and foams. In fact, let's take a look at colloids on page 404. Do you see that? Okay, a sol is a solid dispersed in a liquid. That's why they call it a sol. And paints are sols. Mud is a sol. And a gel is a solid network extending throughout the liquid. Liquid emulsion is liquid dispersed in a liquid, like milk or mayonnaise. I forgot to tell you that a gel is like gelatin, like yellow. And a liquid emulsion is like milk or mayonnaise. It's called an emulsion. Foam is what I use on my face and shaving cream. It's a gas dispersed in a liquid. That's why it's puffed up. The gas doesn't fall out. Aerosol is a solid dispersed in a gas. It's like smoke, airborne particulate matter, auto exhaust. Liquid aerosol is liquid dispersed in a gas, and that's like fog or mist or clouds. Now, what do you get when you got fog and smoke? We have something called smog, and it's a mixture of two solids. Not solids, colloids. Solid emulsion is a liquid dispersed in a solid. It's like cheese or butter. Now, what's the Tyndall effect? Well, if you take a look at the picture on 404, which I will demonstrate in just a minute, if you shoot a beam of light through two things there, you will see the beam of light in the first glass jar, and you do not see the beam of light in the second glass jar. And that's because the first glass jar is filled with a colloid, and the colloid scatters the beam of light. And so therefore it makes a beam. You've all seen, in pictures at least, a shaft of light in between the trees in the woods when there is a fog. And the shaft of light is hitting those little water particles, and it's just scattering the light. And so you see it. In fact, you can see it when you're driving your car. You see a shaft of light in front of your headlights that is scattered by the fog in the air. But then it goes through that second jar, and that's a solution. So the light is not scattered, so you cannot see the light. The light goes right on through it. Okay, so let me show you that. First of all, milk is a colloid. In fact, we had a separate name for it. The milk is called a liquid emulsion because it has fat globules that are big and fat globules that are small. I'm going to go ahead and take the milk. I'm going to shine a light through it. Now, if you looked up there on the ceiling, but you can't see it, maybe if I look at it right here on this, let's try to shine it through there. Do you see it? Do you see it anymore? Or does it block it? Let me shine it over here like this. Goodbye. And that's because when you look at it, that light is being captured right inside the colloid. So the evidence is called the Tyndall effect when you get that shaft of light. It's when light is scattered by colloidal particles because they're medium in size. If you went for a suspension, you're not going to get any light up there in the ceiling, and it's going to be blocked entirely, and it's no, you're not going to see a shaft of light in it because it's opaque to the light. But if you take a solution, let's take some salt water here. Take some solution, and you shine it right on up through the solution. It's going to go right on to where it was headed. You can see that the light is not blocked by a solution. It goes right on through it. Well, you can't see that in the film, but it is, if you were here with me. Here's another solution. This is sugar water. It's called ginger ale. It's full load because it's got a bunch of sugar in it. It's got, if it were a Coke, it'd have caffeine in there. It has preservative. It has some, let's see, some corn syrup in there. That's like sugar water. It's dissolved in there. Carbonated water. It's got carbon dioxide dissolved in there. And sometimes they have phosphoric acid in there, like to give you a tart flavor, and sometimes for preservative. And so what we got here, let's go ahead and fill this thing way up. Whoop. I have to clean the floor. Shine the light through. Shine the light through, and it goes right on through. It hits the wall behind me. If it's a solution, if it's a suspension, it won't go through. And if it's a colloid, it won't go through. Suspension, colloid, and solution. You know what I think I'm going to do? I'm going to quit right there, and we'll do electrolytes tomorrow. Here's the quiz. See ya.